drilling the touch hole through which the charge is ignited. The barrel is complete and needs only to be proofed or tested. This is done by loading 4 times the normal amount of powder along with a patch and ball. This will then be fired from a safe distance.
In normal use, if you fired that amount of powder in the weapon, there would be such a recoil that it would most likely break the stock. We use an old lock to fire the powder train. The barrel is inspected for cracks and swells. These would mean it's no good. Later on, it will be taken back to the shop, unbreeched, and checked inside.
Once the barrel has passed its test, Mr. Gustler begins work on the lock. This is the mechanism that fires the gun. He starts by forging a piece called the cock. The flintlock uses the same principle as starting a fire with flint and steel. The flint, which is held in the cock, strikes a piece of steel, shearing off white-hot bits of metal. These sparks shower into a pan of gunpowder. The fire flashes through the touch hole and ignites the powder charge in the breech.
At a white-hot temperature, the iron is very malleable. With the right tools, it can be shaped into about any form. Like wood, iron also has grain. But in iron, the grain is forced into the shape of the object as it's forged. So a forged part is much stronger than the same piece cut from a solid bar, where the grain all runs in one direction.
"20 or 30 minutes of forging is followed by 2.5 to 3 hours of filing. The most commonly heard sound in an 18th century gun shop was the sound of filing. Literally every part was filed at some time. The file is a simple and ancient tool, and those from sites 2,500 years old look the same as those made today. In the 16th century, Leonardo da Vinci designed a file-cutting machine. By 1770, the craft of file making was highly developed in Europe with all the trappings of guilds and specialists.
I made the pan borer, which is used to shape the cavity for the priming powder. I cut teeth on it like a file instead of making flutes like a reamer. In fact, I make just about all of my tools, except for files and hacksaw blades. Even things like screw plates or dies are easier to make than the lock of a gun. Once the lock plate and cock are finished, the remainder of the inside parts of the lock can be made in proportion to them.
While Mr. Gustler is forging the internal pieces, his helper is at the merchant store buying supplies. Such things as iron and lead, soft coal and charcoal could be obtained within the colony. So could scrap brass, a necessity, since it was illegal to import unworked brass. Flints and powder were customarily imported at this period, yet it was to the colonists' advantage to use as much locally produced material as possible. By the time of the Revolution, much of the powder needed to fight it was being made in the colonies. Now, the inside parts have to be filed to shape, each part being finished in relation to the other parts. The history of guns up through the 18th century can be told in the development of locks which replaced the original hand-held fuses. Early in the 15th century, mechanically held fuses became a part of the gun and were called matchlocks. The wheel locks solved the problems involved in carrying a burning fuse. This lit the powder with a spark-producing device similar in principle to a modern cigarette lighter. At about the same time, the first complicated flint and steel locks were devised. These were refined and simplified until the beginning of the 17th century, when the present form of flintlock was developed. This had but 4 moving parts and was in use for over 2 centuries, longer than any other system to date. As the size and shape of locks varied widely, the screws were made by hand for each individual purpose. Inside the lock, the tumbler controls the movement of the cock. This is held in place by a piece called the bridle, which also holds the sear. The sear engages with notches cut on the tumbler to control it. The sear, in turn, is controlled by the trigger.
The steel is made of an old file welded to a bar of wrought iron. Welding wrought iron and steel is hard to do because they have different fusing temperatures. The file is the hard striking area for the flint. The wrought iron gives it toughness. If it were made entirely of steel, it would be too brittle and very likely break. Sometimes they are made completely of wrought iron and case hardened. In other cases, a piece of steel is riveted or brazed on the iron. Besides being a striking surface for the flint, this piece is also the pan cover.